Section 2.1, Properties of and Simplifying Exponential Expressions. The objectives for this section are to use the properties of exponents to simplify expressions and to be able to convert from fractional exponents to radical form and vice versa. These are the properties of exponents. If m and n are integers and a and b are real numbers, then we have our first rule, which is the product rule. A to the m power times a to the n power, our powers are going to add each other. So that's going to be a to the m plus n. For our next rule, we have the quotient rule, which is a to the m over a to the n. Our exponents are going to subtract each other. So we're going to have a m minus n, where a cannot be 0. For our power rule, our exponents are going to multiply each other. So we have a to the m times n. For our zero exponent rule, we have a to the 0 equals 1. Anything raised to the power of 0, it's always going to be 1, where a cannot be equal to 0. For a power of a product rule, we have a times b to the n power. The n is going to distribute to both of my bases, so a to the n times b to the n. For a power of a quotient rule, we have a over b to the n power. So this is going to be a to the n over b to the n. For our negative exponent rule, we have a to the negative n. This is going to be 1 over a to the n. If for our fractional exponents, we have a raised to the power of m over n. So here we're going to change it to a radical form. This is a radical form. The a is going to go inside. The denominator is going to be our index. And the m is going to go here inside with my base. Or we can also have it like this. And a and that m outside. Okay, let's look at example 1. For example 1, we need to simplify the following expressions. Write all your answers using positive exponents only. For example A, we have negative 6 to the second power. Notice that the second power is only affecting the 6. That means that we're going to have negative parenthesis 6 times 6. The negative stays. 6 times 6 is 36. Okay, now for example B, we have 3y squared times negative 4y to the 4th. We are going to multiply like terms. That means we're going to multiply 3 times negative 4 times y to the second power times y to the 4th power. All right, 3 times negative 4 is negative 12. And right here, for y squared times y to the 4th power, we're going to use the product rule. That means my exponents are going to add each other. So 2 plus 4. And that's going to give me negative 12 times y to the 6th power. Again, over here, you're going to use the product rule. For example C, we have x to the 4th raised to the 2nd power. Right here, our exponents are going to multiply each other, meaning we're going to use a power rule. So use power rule. So we're going to have x, 4 times 2, 8. So our answer is going to be x to the 8th power. For example D, This 6 is going to distribute to both of my x and my y. So we have negative x raised to the 6th power. And we have y to the 4th raised to the 6th power. Now this is going to be x to the 6th power times y. 4 times 6, 24. And over here, we used the power of a product rule. So use power of a product rule. For example, E, we have x to the 7th over x to the 3rd power. This means that my exponents are going to subtract each other. So we have 7 minus 3. And over here, we're using the quotient rule. So use quotient rule. Therefore, 7 minus 3 is 4. So my answer is going to be x to the 4th power. Now for F, we have x times y times z to the 3rd power. Everything raised to the 0 power. This is going to be 1. Why? Because we are using our 0 exponent rule. So here, use a 0 exponent rule. For example, G, we have x to the negative 2. So we're going to write 1 over x. And my exponent, it's going to change to a positive exponent. And over here, we're using the negative exponent rule. So use negative exponent rule. Use negative exponent rule. For example, H, we have 1/3 times x to the negative 3rd power. Now, we're going to break this down because this is the same as 1/3 times 1 over x to the 3rd power. We can go ahead and multiply that. 1 times 1 is 1 over 3 times x to the 3rd power. Now for example 2, it says write each expression in radical form. Here we're going to be using the fractional exponent rule. Okay, let's go back to it. We have a to the m over n equals, we have two forms. It could be this one or it could be this one. Okay, let's take a look at our first example. We have 7 to the 1/2. We can rewrite this as 7 inside our square root. This is not necessary, but you can write it if you feel more comfortable. Or just the square root of 7. For example, B, we have 4x to the negative 4 over 3. So we need to separate this as 4 times x to the negative 4 over 3. And then here we can apply the negative exponent rule. So we have 4 times 1 over x to the 4 over 3. And then if we multiply the fractions, we're going to have 4 over x to the 4th over 3. And then we change this to a radical form. So this is going to be 4 over the cube root, because the denominator is my index, x to the 4th. For example, C, we have parentheses, 5x parentheses, raised to the negative 5 over 4. Okay, so the first thing we need to do is get rid of that negative exponent. So this is going to be 1 over 5x to the positive 5 over 4. And then we change that to a radical form. So it's going to be 1 over, the index is 4, 5x, keep her in parentheses, to the 5th power. Now for example D, we have parentheses 10n, parentheses raised to the 3 over 2. So this is going to be square root. Again, it's a square root, so you don't have to write the 2 if you don't want to. 10n raised to the 3rd power. All right, so for example, E, this one you can try it out. Try it out on your own. And for example, F, I think this one you can also try it out on your own. So try it out. For example, G, we have x to the negative 3 over 8. So we change that to a positive exponent first. So we have 1 over x to the positive 3 over 8. And then we change it to a radical form. So 1 over, remember the denominator is my index, so that one goes outside, x to the 3rd power. All right, and for example H, we have a to the 6th over 5. Again, the 5, it's going to be my index, so that one goes outside, and a to the 6th power. Now for example 3, we need to write each radical expression in exponential form. Okay, so our radical expression, it's n to the m, or we can have it in this form as well. And this is how it's going to look like. All right, let's look at the first example. So we have the square root of 6p. Again, 6p, it's all inside the root. When it doesn't have an index outside, it means it's a 2. And here my exponent is a 1. So this is going to be 6p raised to the 1/2. All right. So for example, B is looking in this form. So my 6x is all inside the root as well. So it's going to be 6x raised to the power of, remember the index is my denominator, so it's going to be 4 over 3. Let's take a look at example C. I think this one you can go ahead and try it out on your own. So for example C, try it out. All right, let's look at example D. So I have 1 over the square root of x. Again, this is going to be 1 over the square root of x. My index is a 2 and my exponent a 1. So it's going to be x to the 1/2. And here we need to apply the rule of negative exponents. So this is going to be x to the negative 1/2. For example, E, we have 4 over the 5th root of x to the 4th power. So here we have 4 over x. Again, my index is my denominator, so it's going to be 4 over 5. We apply the rule of negative exponents, so it's going to be 4 times x to the negative 4 over 5. And for example, F is very similar to example E. So this one, go ahead and try it out.